This is 2018 question 5, paper 1. Right, the diagram on the right shows the graph of a quadratic function f. So function, quadratic function, function, paper 1, function. So it looks like somewhere in here we're going to have to do some differentiating. Okay, so that should be at the fore of your mind now, okay? We're in a functions question, paper 1. Expect to do some differentiating. I could be wrong, but that's kind of, I'm thinking that way, okay? I'm kind of getting myself prepared. I'm looking for it because it could be hidden away. Right, write down the coordinates of A, B, and C. Ah, lads, look how easy that is. Like question 5, and they're asking to find coordinates 0, 6. B is going to be -2, 0, and C is going to be 3, 0. Show that the function can be written as that thing there. So I'm going to have to put this information into here. And I'll put all 3 in. So I'll put in f of 0, and I hope f of 0 will give me what? I hope it'll give me a 6, because 0 gets turned into a 6. So does that happen? 0 plus 0 plus 6 is equal to 6. Yes. True. Let's try -2. F of -2. So when I put in a -2, I hope I get out a 0. Let's try that. Is equal to minus bracket -2 squared plus -2 plus 6 is equal to, is that equal to 0? I need to check that. So I have to do the squaring first. That's -4 -2 plus 6. Is that equal to 0? Well, -6 plus 6 is equal to 0. True. So we've done the first two, and now the second, or the last one, is going to be f of 3, and I hope that will give me a 0. So we have to check, is it equal to 0? So it's going to be -3 squared plus 3 plus 6. So that's going to equal -9 plus 3 plus 6, which is equal to 0, and then -9 plus 9 is equal to 0, so 0 is equal to 0, true. So each of these 3 points is on this function, so it looks like it is the function. Yep, job done. Show using calculus. Here we go, calculus. That's kind of a fancy word for differentiating for you guys. Show using calculus the maximum point of this thing here is at this point here. So we're asked to show that the maximum of, oh, my pen is dead, sorry, I'll just charge it up. So I'm asked to show that a maximum point. So again, I'm going to have to differentiate. The moment you see calculus or anything, you're differentiating. Okay? You're going to get up marks for differentiating. Even if you don't know how to find maxima, you'll be able to get the marks for differentiating. Of course, finding maxima is very, very easy, because we know at the very tip of our function, the slope at that point, the very top of our function, up there at wherever it is, we know that the slope at that point is equal to 0. So we're going to differentiate first of all. So we have f of x, and we're kind of using the English notation. So we have minus x squared plus x plus 6. So we now have f prime of x is equal to minus 2x plus 1. And I want to know, when is that equal to 0? Because up here, the tangent at that point, its slope is going to be 0. So therefore minus 2x is equal to minus 1. X must equal to minus 1 over minus 2. So x must equal to a half. Or I think what we want to see is x is equal to 0.5. So I've now worked out the x value. To get the y value, I have to put it into the original equation, or the original function. So I'm going to have f of 0.5 is equal to minus 0.5 squared plus 0.5 plus 6, which is equal to, it's a calculator job I think, minus start bracket 0.5 squared plus 0.5 plus 6 is equal to 6.25. Yep, so that's what we had to get. So we got our points here. Job done. If we could maybe think about this an easier way. If they didn't force us into using calculus here, we know that this point here is halfway between our two roots, yeah? Because this curve here is symmetric, this must be halfway between our two roots. So if that root is -2 and that root is 3, how do we find the middle of two numbers again? We came across that when we were looking at median. So to find the middle of two numbers, we add the two together. So it's going to be -2 plus 3 is equal to, so -2 plus 3 is equal to, and then we divide that by 2, so we get a half again. So yeah, everything ties in together nicely there. Was that it? So that was it for question 5. How nice of a calculus question was that? Yeah. Find out some coordinates, throw those coordinates into a function, and then do a bit of calculus. Very, very handy. Very, very, very handy indeed, lads. Okay.